Okay, welcome back, students. In previous class, we have seen the de Broglie's equation of atomic structure, first chapter. Now we will go for next is Hessenberg uncertainty principle. We know that every object is moving in its specific path. For example, if we consider the moving car or moving motorcycle, or consider that planets are moving in a specific path or direction. So, in all these examples, the path of an object can be determined by knowing its velocity and its momentum, velocity and its position. Now, when this rule is applicable to microscopic particle, it is not possible to determine the position as well as momentum of the moving particle like electron at the same time. For example, if I am going from uh, one place to other place, so I have to move by specific velocity and I have to go to a specific path through the specific path. For example, if I want to go from Maulana Azad College to railway station, so what happened? I have to follow the specific route and I have to follow through, or I have to go through the one velocity or specific momentum. So if I move from my starting point like Maulana Azad College, so I will go to Rozabad. So my position will change when the time is going to change. So from Maulana Azad College to Rozabad, the velocity can be determined. Now when this rule is applicable to moving electron around the nucleus, this moving electron or the velocity and the position of the moving electron cannot determine at the same time. Now this concept was given by Hessenberg, Werner Hessenberg in the year 1927. Just I am sharing the screen and to explain the Hessenberg uncertainty principle. Now, the Werner Karl Hessenberg, born in the year 1901 and died in 1976, he received the Nobel Prize in Physics in 1932 for his work in nuclear chemistry. His most popular or most expected research paper was on uncertainty. Now, we know that every moving object is having the specific path or specific direction. So, Hessenberg has proposed that it is quite impossible to determine both the position and the momentum of moving particle at the same time. So this concept of Hessenberg now next converted into the principle, and we know that it as Hessenberg uncertainty principle. The word uncertainty means it is quite impossible to determine both the things at the same time. So on that basis, the principle states that it is impossible to measure simultaneously the position and momentum or velocity of a moving microscopic particle with great accuracy. This is explained by means of rule or derivation del x into del p, which is equal to or greater than h upon 4 pi, where del x is uncertainty in position, del p is uncertainty in momentum, which is always equal to constant, and that constant value is given by h. This h is nothing but Planck's constant. Now hereby we can easily understand this principle by taking one example. For example, जैसे कि एक पर्टिकुलर स्टूडेंट है और वो फुटबॉल का प्लेयर है और हॉस्टल में रह रहा है। अगर मुझे ये मालूम करना है कि वो स्टूडेंट फुटबॉल प्लेयर है, तो मुझे उसको देखना है खेलते हुए या उसे उसे मुझे देखना है ग्राउंड। सो दिस इज नोन एज अ वेलोसिटी। अगर मुझे ये मालूम करना है कि वो स्टूडेंट जो हॉस्टल में रह रहा है, तो जब वो हॉस्टल में मौजूद रहेगा, दैट इज इट्स पोजिशन। बट सेम थिंग, दैट इज position of the student in the hostel and he is the cricket player, means he is playing on the ground, both cannot be determined at the same time. This is the simple principle or simple example of understanding. So physical concept of this principle is If this is applicable, one should know how the position of material object is determined. Next, when a beam of light strikes, so here we will see by example, by taking an example. So this is the Hessenberg uncertainty principle. Here, this is the del x, which is known as uncertainty in principle. This is del p, which is uncertainty. Uncertainty means it is impossible to determine or in inaccuracy. Now we will go for how to apply this rule. Now this rule is applicable to macroscopic particle only. Now, if I am moving from one place to other place, it is quite possible to determine the position as well as velocity of the moving object when we consider the macroscopic particle. But the electron, which is microscopic particle like electron, neutron, proton, these cannot be seen by naked eyes. Now, in order to see the electron or the position and velocity of electron in a specific orbit, here we have to look this electron by means of microscope. Now suppose here this is the electron which is moving in the specific path or specific orbit, which is known as energy level. Let's do that. Suppose here this electron is moving in a specific path. This is the path of electron which is moving like this. Okay, so here it is the moving electron. That is the just I will take the one pen. Let me do easy. Suppose here this is the electron which is moving in this path. Suppose here it is the path of electron which is moving around the nucleus. Okay, this is the orbit of that electron. Now, if we want to know the position of that electron, okay, so here we have to look the electron, we have to see the electron, but it is quite impossible when the microscope is incident on that electron. Suppose here this is the position of that electron, this is the position of that electron. So here it is the position of electron. Okay, this electron will going from here to here, here to here, here to here. In this way it is moving in a specific path of in orbit. Now when this electron beam is incident on that electron, this in microscope will having the, we can look at the electron by means of this microscope. So microscope will show some radiation, or by the help of light of this microscope we can look the electron. But when this electron is interacting with the light, this electron when interact with the light, it will change its position. This position now has been changed. This is the position which is changed due to interaction of the light of the microscope. Actually the velocity or the path of that electron was was the path, this was the actual path before incident of the microscope. So here this electron is now traveling before the incident of microscope. This is traveling in this direction like this. Now after incident of microscope, when the light is incident on that microscope, the path is going to change due to some energy which is given by means of this microscope. The position of that electron is changed. Now this will be the new path which I have shown you by means of yellow color. This electron absorb the energy from microscope, and after absorption of energy, it shows various orbit or various path of that electron. So here, when we are interested to determine the position and momentum of the electron, we require the microscope, because all these particles are microscopic particle. So it is impossible to determine the velocity or moment position of that electron with great accuracy, because of the interaction of the microscope, light of the microscope with the electron change its actual position. सिंपल कंसेप्ट में ये समझ सकते हैं कि इलेक्ट्रॉन जो रहेगा, पहले इलेक्ट्रॉन माइक्रोस्कोपिक पार्टिकल है, ये क्या करेंगे अपने स्पेसिफिक पाथ में रोटेट होते रहेंगे, इस तरह से रोटेशन इसका होते रहेंगे. सपोज हियर it is the path of electron. Suppose this is the path. Just a minute. This is the path of electron which I have shown by means of yellow. येलो कलर से मैंने इसका पूरा सर्कुलर पार्ट है, ये सेंट्रल पार्ट जो है इसका न्यूक्लियस है और ये ऑर्बिट. इलेक्ट्रॉन यहाँ पे मूव होते रहेंगे, कंटिन्यू मूव होते रहेंगे उस तरह से। अब हमको देखना है कि इलेक्ट्रॉन का पोजीशन क्या है या उसका वेलोसिटी क्या है, तो इसके लिए हम माइक्रोस्कोप यूज करेंगे, माइक्रोस्कोप, दिस इज द माइक्रोस्कोप। अब क्योंकि ये पार्टिकल बहुत स्मॉल है इसलिए माइक्रोस्कोप की जरूरत है। अब ये जब माइक्रोस्कोप का लाइट या रेडिएशन इस पे पड़ेगा तो इसका जो एक्चुअल जो रोटेशन है वो चेंज हो जाएगा या रिवॉल्यूशन चेंज हो जाएगा। क्यों? क्योंकि माइक्रोस्कोप की जो लाइट की एनर्जी एब्जॉर्ब करके इसका जो नया पाथ आ जाएगा या नया डायरेक्शन आ जाएगा वो इस तरह से, ये जो डायरेक्शन है इसका नया। तो हेसनबर्ग ने यही कहा था कि कोई भी माइक्रोस्कोपिक पार्टिकल का एग्जैक्ट पोजीशन और एग्जैक्ट मोमेंट, एग्जैक्ट वेलोसिटी और पोजीशन एक टाइम पे मालूम नहीं कर सकते। अगर आप इसका वेलोसिटी मालूम करना है तो इसको माइक्रोस्कोप से देखना पड़ेगा, और जब वो इलेक्ट्रॉन ये माइक्रोस्कोप का लाइट एब्जॉर्ब करेगा तो उसका डायरेक्शन चेंज होगा क्योंकि उसने माइक्रोस्कोप की लाइट की एनर्जी एब्जॉर्ब की। सो दिस इज द सिंपल प्रिंसिपल ऑफ हेसनबर्ग अनसर्टेनिटी. So Hessenberg uncertainty principle simply explained that it is quite impossible to determine both the position as well as momentum of the particle at the same time. This is this law states that it is denoted by means of equation del x into del p, which is equal to or greater than h upon 4 pi, where del x is uncertainty in position, del p is uncertainty in momentum, which is equal to h, that is a constant value h upon 4 pi. Now, these are the significance of this principle. So in our day-to-day life, this principle has no significance because we come across large object, that is object we can see with our naked eye. It is possible to determine the position as well as momentum of the macroscopic particle like car, motorcycle, ball, like this small. But for microscopic particle, it is quite impossible to determine both the position as well as momentum. Now, here we will see the numerical based on this. So calculate the uncertainty in the velocity of electron if the uncertainty in position is 100 ppm. So given value is what? Mass of electron is given 9.1 into 10 to the power minus 31 kilogram. H is a Planck's constant. Now keep the value of keep this value, that is del x is also given, uncertainty in velocity which is del p, uncertainty in position is del x, here position is del x, it is also given. Then uncertainty in velocity is also given, keep this value in this equation, keep this value in this equation, del x is given, del p is also given, h is also given. Now we have to calculate, sorry, calculate uncertainty in velocity, we have to calculate, means del p we have to determine, and which values are given, h is also given, m is also given, x and del x is also given. So we have to determine the del p, uncertainty in the velocity. So here these are del x, del p equal to or greater than h upon 4 pi. Now here this equation we will solve this problem by taking, I have already solved this question and this one numerical. Okay, this I will share one numerical, that will be very easy. Let's wait for some time. It is opening. So these are the numerical based on that equation. Okay. Okay, so we don't copy. So this is the equation del x into del p, which is equal to or greater than h upon 4 pi. Oh, sorry, this is not that equation. Del v is it. Okay. So keep the value of del x. What we have to calculate? We have to determine the. We have to calculate the del p. Here this equation is different. So in numerical, you keep the way you kept the value of change in momentum, change in position, and value of h and calculate. So that will give the answer. Thank you. Now we will see another principle, of principle. Okay. Next principle is the output principle. So here we will stop. Next we will see